Alright guys, welcome to today's lesson. Title is Finding Functions, and the learning objective is written there. I want you to read it to yourself and make sure you understand what it's talking about. It will probably make more sense once I've done the first example. So just make sure you've written the title, have a read of the learning objective, and press play when you're ready to keep watching. So far, we've looked at how to integrate functions. So for example, if we know that dy by dx is equal to 3x squared, what would y be? Pause the video so that you've got time to do that. This is the sort of expression that I'm hoping you're now probably aiming to integrate in your head. So you're saying to yourself, I know that it has to be x cubed in order to differentiate to x squared, but when I do that, I get 3x squared. Oh look, that means I've done it perfectly because the coefficient is exactly what I want it to be. However, until now, we've always had to write plus c here because we don't know, given the information that we're told, what the value of c is. And hopefully you remember from the first video, there's an unlimited different combination of functions and I could go on literally forever, that all differentiate to give this. So that's why we write plus c there, is because we don't have enough information to say what c is. And also because it doesn't matter what's there, it will differentiate to make 3x squared. So just so that you can, I'm going to show you what that looks like in the graph now, because I think it's quite nice to see. So if I write y equals x cubed plus c, I'm going to add a slider here. What this means is, when c is 1, you can see the y-intercept is 0, 1. And as c changes, the y-intercept changes, but the shape of the graph doesn't really change, or it doesn't change at all. The gradient function of the graph is the same regardless of what c is. So that's just confirming on the graph what we already know. However, if I were to tell you that the gradient function is this, and the curve passes through the point, let's say 211, how could I use that information to find out what c is? Pause the video and have a think. Well, hopefully you've read the learning objective. We're going to substitute given values for x and y. In other words, we're going to substitute in this case 2 and 11 because they're given to us for x and y. So that means instead of y I'm writing 11, instead of x I'm writing 2. And that will enable me to solve to find c. When I do this, in this particular instance, I'm going to get 11 minus 8, so c will be equal to 3. And now I can say a specific function which has a first derivative of this and goes through this point, the specific function is y equals x cubed plus 3. So you can see we're taking this one step further because we're now given more information. We can say more about the original function. In fact, we can describe it perfectly when we're given a point. So let's just show you what that looks like on the line. So if I make c equal to 3, let's just change it so it's like that. When I zoom in here to the point 211, you can see it's on that line there. That's annoying. There we go. You can see it lies on the line, which means c must be 3. So that's what today's video is about. We're going to do one more example, and then you're going to get on with exercise 13C. So I want you to pause the video and have a go at answering this on your own. Play when you're ready for me to go through it. So this is quite a nice question because it combines a few of the different things we've been looking at. So we're told f dash x is equal to x squared minus 2 all over root x. This is one of those situations where I've not got it all in one line because I've got some denominator here. I've got x as a denominator, and I've also got a root sign. So I need to deal with this by making it x squared minus 2 over x to the half, which is the same as x to the negative a half times by x squared minus 2. But remember, we've got two terms here which we need to expand, because when we're integrating, we need to have individual terms. We don't want to have things that are being times together for now. So x to the power of negative a half times x squared is x to the power of 3 over 2. And then we've got negative 2x to the negative a half. So this is the expression that I need to integrate. I'm going to do my working up here. If you want to try and do it in your head, then please do. I know that x to the 5 over 2 is what it would have originally been, because that differentiates to this, which gives me the right index number here. Looking at this one, I know that I need x to the half, which differentiates to a half x to the negative a half. And so now to get the right constant, I need 5 over 2 to become 1. That's going to be 2 over 5, reciprocal. And I need a half to become negative 2. So I'm going to times that by negative 4, because negative 4 times a half is negative 2. So this is my general function of x. It's 2/5 x to the 5 over 2 minus 4x to the half plus c. But today's video, is about finding the specific function that passes through this point. So now that I've got f of x and I'm given the point 45, I'm going to substitute x is 4 and y is 5 into that function. So when x equals 4, 5 equals, or f of x equals 5, I'm just going to write that nicely underneath. 5 equals 2/5 4 to the power of 5 over 2 minus 4 to the power of a half plus c. So what I'm doing there is I'm writing out this function, but instead of x I've written 4, instead of f of x I've written 5. I'm now going to solve to find c. So 5 equals, well, that is 32 times 2, 64 over 5. Obviously you can do this in your calculator. 4 times 2 is 8 plus c. And then add 8 to both sides and take away 64 over 5 from both sides. Just doing my calculator now, and I get c equal to the 5th. I've not yet finished though, because I now need to combine that with my function so that I can find the equation of c. So my answer is f of x equals 2/5 x to the power of 5 over 2 minus 4x to the power of a half plus 1/5. You could have written y equals that as well. That is my answer. So if you need to rewatch any part of that for it to make more sense, then obviously please do. And if you're still having trouble, then obviously email me or Ms. Cooper for some extra help. And then good luck with exercise 13C.